I'm ready. Welcome back. Hope you had a good, nice little weekend. We are still talking about Turing machines. We do have homework due tomorrow. I hope you've had a chance to check it out. There's just a fistful of Turing machines on there. They can be a little tricky. I would be happy to chat about if you got questions. Anyway, let's just do a couple more. So I had two more examples. I got one to get us going, and then I have one for you all to try. And then we'll go on and talk about something slightly different. But we're still in the just sort of lots more examples of increasing complexity, although they're not really going to increase very much beyond this first one that I want to do here. So let's try one more example of a Turing machine, and then I got one for you all to try. How about a Turing machine for this language, XCX, where X is any string on A's and B's. All right. So it's something followed by a C, followed by the same something that you saw at the beginning. So something like, A, B, B, C, A, B, B. That's the kind of a thing that you're going to see in this language. The X is only with A's and B's, and then it has a C in the middle. All right. This is vaguely like there was something on the homework. There's one that looks like this, which is kind of similar, although this one on the homework is easier because it's just A's here, has a B in the middle, and then just A's again. But the strategy you should use for this one here is similar to this one over here. You should, as with most of these, you should be sort of mark off one letter at the beginning, and then move to the right and mark off the appropriate matching letter on the other side of the C, which is not all the way at the end. It would be right here. So my strategy here would be mark the first A. Like this is what we begin with on the tape, but then after one step, you would mark this A off, and then after the next step, I would move myself to the right, past that C, and then mark that A off. All right, and then go back to the beginning, and then mark the next letter at the beginning, which is the B there. So my next little step would look like this, and then go to the right, past the C, and mark off the matching B on the other side, so it would become that, right? Etc. Actually, there's not much more to that, but I hope you get the idea. This is my strategy. We mark off a letter at the beginning, and then move yourself to the right through that C, and then mark off the same letter at the end. And this is where this one here is a little bit trickier than this one, because you have to mark, sometimes you're going to mark an A at the beginning and then mark the appropriate matching A after the C. But sometimes you mark a B at the beginning and then you mark the appropriate matching B at the end. So after the first mark, you kind of have to remember, was it an A that I marked or was it a B that I marked in the first step? And then as you move to the right, you have to remember that so that you can mark the same letter at the end. And the way that you do this kind of remembering, you don't really, you can think of it like remembering, but the proper way to do this is with two branching paths. And we did one example like this last time. I just wanted to do another one. Two branching paths. And the two paths are according to whether the thing you marked first was an A, in which case the next thing you mark has to be an A, or was the thing you marked first a B, in which case the next thing you mark has to be a B. So two branching paths. One is if we marked A versus if we marked B. All right. Of course, you have to do a little bit of something to handle the C in the middle, but we'll get to that when we get to it, I guess. All right, this is the basic strategy. So from my starting point, and actually this two branching paths will occur immediately at the start, right? When you begin, either you're looking at an A or you're looking at a B. And so I'm going to make my two paths immediately. One will mark a A and move to the right, and one will mark a B and move to the right. Now these two paths will do basically the same thing. It's just when it finally arrives on the right side of the C, it will mark either a A or a B, depending on which path it's on. All right. In any case, what are we going to do from this point up here? This is my starting state, by the way. Let's write out sort of the top path first, and then the bottom path will be basically the same. Anyone want to suggest what should happen here? In words, I would say you want to move to the right over and over again until something, I guess. Any ideas? Yeah?
You want to go through everything until you see a C?
Yeah, right. We should move through everything until you get to a C, and then like something special should happen, I guess. So move to the right through everything. The way you write that is like this, AAR, BBR, right? Until you get to the C, that's when something special happens, I guess, although, I mean, you don't do anything to the C, so I'm going to go CCR. Now we're on the other side of the C, and I think at this point we need to continue moving to the right through any previously marked things, if there were already marked A's and B's on the right side of the C. So from here, I'm going to say A bar R, B bar R. That means continue moving to the right through any previously marked letters. And then finally, we should arrive at an unmarked letter. And if we're on the top branch, that letter better be a A, not a B, right? And if it is a A, I'm going to mark it and then move myself back to the left. And actually, this is the point at which the two branches will come back together again. So I'm going to, sorry, A bar, L. So this is, the two branches basically are going to look like this, right? This is the one where you started by reading an A, and at the end, you read another A, all right? And this one is going to be basically the same, but it begins with reading a B, and at the end, it reads another B. So let's fill in the bottom path here. It's all the same. This is, again, AAR, BBR. That means move to the right through any A's or B's until you get to a C. Again, you want to just move past the C and continue moving to the right through any A bars, A bar R, B bar R. And then finally, you will arrive at an unmarked letter. And if you're on the bottom path, it should be a B, unmarked B. And I go B bar L. All right. Those are my two branching paths. So at this point, when we're, over here at the end of the two branching paths, we have just marked off the thing on the right side of the C, like right here, all right? And now, to get back to the beginning, we want to do that whole thing over and over again, to go back to the beginning, mark something, and then back to the end. I'm going to make it into a big sort of a loop by going back to the starting state, and it's convenient to draw that through the middle, or you could make a giant sort of loopy shape, but I think it looks cooler if you draw it back through the middle. What do we have to do to get back to the left? I need to move to the left. Actually, I'm going to do this kind of in two steps. First, we should move to the left over and over again until you get to the C. And that involves moving through bars. Now, I can actually do that right here. So I'm going to say here, move to the left through barred letters. A bar L, B bar L. I'm moving back to the left through, first of all, through previously marked letters, and then I'm going to see a C. I'm going to go sort of halfway here, CCL. And then from there, I hope you left enough room inside. Maybe I didn't. I'm going to have a little loop on that guy in the middle. This is sloppy, sorry. I know it's hard for you to do this on real paper. I'm going to do that. This goes down here. All right, on here, I have to move. So after the C, I'm going to continue moving to the left, like over here, through some unmarked letters. So this will be AAL, BBL. And then finally, when I see something which is marked, that's how I know I'm back to the beginning. So I'm going to go A bar R or B bar R. So you move back through unmarked letters until you see a marked one. And then you're fully back sort of to the beginning, ready to mark off your next either A or B. This is a little complicated, pretty fancy looking, in my opinion. Any questions about that so far? We're not quite done, but this is basically the guts of it. All right. Okay, what about, now we got to think about how we actually finish this off. At what point do you realize that you're done here? Now, as we've seen, if you remember from previous examples, usually it's from the starting state that you realize you're done. The reason is because we are basically doing a big loop over and over again, either going across the top or going across the bottom. And how do you know when you're finished? I mean, if you're doing a loop, you know when you're finished after you've done the last time through the loop, in which case you're going to end up back here after the last time through the loop. So you will expect usually the end game will sort of be a branch off of the starting state. And in this case, how do can anyone say, how will I know when I get back here if I'm done marking off my letters? You can think like what's actually going to happen once I get, if I had continued this like from this one, the last step will be like this, right? Everything will be marked. Yeah?
Blank?
I think after doing this loop through, if you're done, you're not going to see a blank here, because actually after you do this loop, you're not going to end up over here. The head will not end up on the end. I think it ends up there because it goes, the last thing that happens in this loop is moving past the C to the left and then back through any unmarked things. When you hit a marked thing, I move back to the right by one position. I believe the last time through, you will be in this state and you will see a C. All right? That's what's going to happen your last time through this big loop. And so that's what's sort of the trigger for my end game here. So this, I'm going to put maybe a CCR. So if you see the C in that state, it means you've already marked everything before the C. Now, we do need to make sure that there's no leftover funny business after the C, because we've marked off everything before the C. Have we also marked off everything after the C? In order to do that, this is similar to a lot of the other examples we do. You need to make a little loop here, which just moves to the right forever, and make sure that everything is actually marked. So that's going to look like this. A bar, R, B bar, B bar, R. This means I'm going through the rest of the string and just checking to make sure everything has been marked off. That is to say, make sure there were no extra letters after the C that didn't get matched with anything before the C. And if they really are all marked like that, then you will eventually get to a blank, and that will be my signal to finally accept. So I'll put BBR here to an accepting state. All right, so that is just, this is a common thing that we have to do in these examples. You have your main machine up here, which is doing all the marking, and then you just have to check to make sure that everything really got marked appropriately at the end. Any questions about that? These, in my opinion, are fairly difficult, especially after a long weekend. I assume you weren't doing this till the break of dawn every day over the break. It's all right. Any thoughts? I got one for you all to try, which is similar to this, maybe a little bit simpler. I don't know. We'll see. Sometimes I have a hard time telling what's easy and what's hard. Your job is a Turing machine for this language. On the surface, this looks totally different, but actually it's quite similar to what we just did. X equals X reversed. All right. That means the string reads the same forwards and backwards. So I will give you sort of my concept here. A typical string in this language is something like A, B, A, B, B, A, B, A. I believe this is the same forwards and backwards. What's your, you do most of these by marking. And my strategy for marking in this case would be something like, that's what I start with. I'm going to mark the first A and then run you have to think about where's the matching A for this one here. It's actually all the way at the end. So I begin by marking the first A, and then I run all the way to the end and mark the A at the end. And then you run all the way back to the beginning. I mean, not the total beginning, but back to that first B there. Mark that off, and then run to the end and mark off the corresponding B. Again, you are going to need this sort of two branching paths, depending on if the first thing you see is a A or a B. And there's no C in the middle, but it's vaguely like the one that we just did. So see what you think. I'll give you a few minutes. If you think these are hard, then you're right. In my opinion, they are kind of hard. You got to get used to it.
Yeah, that's great. I think I'll probably want L because that's needs the that row, right? Yeah. I mean for all of those. Just in that
Doing all right?
I like that so far.
Okay. In progress. Mm-hmm. Yeah, you can go all the way to the end. Yeah, you can say like blank L, and maybe back down. Although in later steps, actually, you shouldn't even make it all that. So it's really a blank, but also to be
I love this here. Okay. So this we're at this point is like moving across here, and then you have to think. Actually, there's a step that you can say. You just write down each time you mark this one first, but the last one still. That's actually what we're doing here. And you need to write that the last one still. So I would say you make it instead of that. You actually you have to go to the right one so you get all the way to the end. How's it going? Yeah, this is good. So this says mark the first thing, and then you want to move through all the other things. So this goes through these. Okay, but yeah, you have to mark this thing first. How's it going? I was gonna say that's very complicated.
Yeah, trying to write it out.
Yeah, this is us.
I don't know if I just think it's
So that's not it. So at this point you have marked first.
yeah.
When they're in here, you can mark the last thing.
Okay.
You should be right. Mark the other thing.
Okay.
I
Got it.
should get to the very end. And you gotta back it up one, so you do want something.
Okay.
Yeah, it's much easier. Like if it says.
Yeah, that's great.
So then would the like accepting thing and then here, then you're in the back of the middle function that include.
You end up back in the middle eventually, right?
So then
You end here if what happens.
if it is you take it backwards. So
You get to a blank, you mean?
I guess if there's nowhere to go, there's no question.
Yeah, I don't think it's. Yeah. Let's go on. Good structure there.
So it should be like you get
So
to
you mark the
and then
first
instead
thing,
of in here.
you move to the right, triangle the other ones.
Or just go take it down.
I would
No,
say
then you still have to run through that.
eventually
It's still
go all the way to the end and go to a line.
and then get to it.
And you should back it up. So I think that's what it's.
So this should be should be. So just be doing that.
This should be flying up. Because you go all the way to the end. And you gotta back it up by one. And then that's
So just.
yeah, I don't think we really need
Okay,
that.
and then that's fine,
Huh?
and then this should be one.
This should be similar to that. Good? Oh, this is pretty good. Yeah, you don't actually have to run. Yeah, that's pretty good. So, how's it going? No. Structure this is good. X is a string. There's no way.
All right, let's chat about it. I saw some varying levels of success as I went around. Maybe when I drew this, maybe I should have written sort of another step. Really, this going from here to here requires sort of two main steps. First, you mark the first A, and then the second A is not marked yet. As I was writing the previous examples, I wrote it more like in this style. I'm just trying to give you an idea of the various steps involved. But the first thing you mark is at the beginning, and then you have to move to the right until you get basically all the way to the end, or perhaps all the way to something which is the last thing which is not marked. So what I need to do here is go to the right through every unmarked A and unmarked B. And as you go through all of them, like in this example, I'll just run through the whole thing and end up with a blank, and that's how I know that I got to the end. And so here is going to be a big B, big BL. All right? I ran all the way to the end and reached a blank. Now, sometimes, like the first time through, you really are going to get all the way to the end and see a blank. Although in later times, maybe I'll mark this first B and then I'll run through. Actually, you won't get to a blank. You'll get to this A bar. But I want to do the same thing. So here you also need A bar L, B bar L. These are for later iterations. You won't actually make it all the way to a blank at the end. You'll make it to a marked letter. And at that point, you should move back by one position. And then you should be looking at the other letter that you're trying to mark. And since I'm on the top branch, that should be an A, which I'm going to mark. That is turned into an A bar. And this is the full sort of top branch of this path. I hope you got something like that. As I was going around, I saw. You don't need another loopy thing right here, all right? The loopy things are to either move to the right over and over again or move to the left over and over again, but that's not necessary here. I've already gone all the way to the end. I back it up by one spot, and then I mark the letter right there. You don't want to back it up by many spots. All right? The bottom branch looks the same. So here I again have AAR, BBR. Here I have a bunch of bar things. B bar L, A bar L, BBL. That is blank blank L. And then finally marking a B at the end. B bar L. All right. This is the main branching paths. And then we need to go back to the beginning after you've done this, you've done one sort of marked an A and then marked the corresponding A at the end. You need to go back to the beginning, that is to say, move to the left through any A's and B's until you see a barred thing. That's when you know you made it back to the beginning. So that can be accomplished right here. I'm going to go AAL, BBL. That is moving back to the left. After I've marked that final letter at the end, I got to go back to the left, and that should be moving through ordinary A's and B's until I see a marked A or a marked B. That means I went one step too far and I moved back one to the right, and I'll be back at the beginning of my loop. So it's like this. A bar, R, B bar, R. And this is really the full sort of big loop. I hope that you said something like that. Anybody got questions so far about this? If you did it slightly differently, it might be right, but probably it's not. These actually are a little touchy. I mean, there is a fair amount of, when you're doing this, you can feel creative about it, but actually there's a fair amount of rigidity. It's difficult to give a slightly different answer that's still correct. Yeah?
So when we say like the L, like move to the left, does that mean the head is going to continue moving to the left? Like the next letter you look at is also to the left?
Yes, I think so.
Okay.
I'm not sure what you mean. If you mean by continue, like it'll move to the left over and over again, that only happens if you do it in one of these loops like this.
Right, but if you have like
Say this A bar L
yeah,
means,
does that mean now the head is pointing to move to the left?
yeah, to the left of that new A bar that you
Okay.
made. Yep. Yeah, that's what the L means. Yeah, for some reason I experience this kind of, I feel like moving to the right makes more sense to me than moving to the left. I don't know why that is, but I I don't think there's any like truth to that. It's just the devil on my shoulder telling me moving to the left is weird, but moving to the right, I'm a right supremacist. Maybe I don't know why I feel that way, but maybe you feel that way too. All right. Okay, now we're not quite done because we have to say at what point the thing is accepted. And this is slightly tricky in this example because the acceptance happens, like in this particular example, if you continue this process until the end, what you're going to end up with is everything marked. And actually, the head will end up in the middle somewhere, right? If you do this loop properly, where you will end up, you're going to move to the left. After the last thing you marked will be this B bar. And then you move to the left, but actually you have nowhere to go. Like this loop to the left will not happen, although you will have moved to the left after moving this B bar. So the head will be pointed here. It will immediately do this and move to the right by 1. And it will be pointing at a bar. So the way to detect the end is if you're in this state and you see a barred letter. That means that you've marked all the stuff from the beginning. And so from there, if I see an A bar or a B bar, and actually if you think about the way this goes, usually we have to run through the whole string one more time to make sure there was no extra stuff left over on the end, but that's not really possible in this, because we were doing our loops from the beginning all the way back to the end. It's not possible for there to be extra stuff sitting on the end. So actually if you see a barred letter right here, then you are sort of well and truly done, and there's no more stuff you have to do. So I'm going to do A bar or a B bar moves you into the accepting state, and that's it. Sorry, I'm off the screen a little bit. Now, this is almost completely right. Did anybody have any more thoughts about this example? Because actually this is not completely right as I've written it here. The word that I wrote here, or this string that I was using as an example, actually there can be other kinds of strings which have this property, x equals x reverse. For example, here's another example. How about A, B, A, B, A? This is a string which reads the same forwards and backwards. Can I say what's different about this one? Actually, it is different in a way that matters here. Yeah?
More A's than B's.
Yeah, there's more A's and B's, that's true, although, yeah, that's not exactly, there's fewer B's than A's, that's true.
There's an odd number of characters.
Yeah, there's an odd number of letters here, which means there's an extra letter in the middle, which will never get matched with anything else, all right? And that actually will mess up this machine here. You will have an extra letter in the middle, so you're gonna, like, eventually I'll go through this, I'll mark, it'll work like I mark this A, then this A, then this B, then this B. Then I will mark this one and then start moving to the right, but I will find no other one to mark at the end, right? Because there isn't any other. So as written, this string will be rejected on this machine, but we want it to be accepted. And fortunately, there's an easy workaround. You don't have to just like redraw the entire diagram. If there's an extra letter in the middle, what will happen is I mark this letter in the first step, move to the right, but that's not going to happen because everything else is marked. I will immediately go left, so it'll mark this A, move to the right. Then this step will cause it to go back to the left. I will be looking at the same one that I just marked right here. And actually, this is how you handle it. It's possible the string can be accepted right there. And that is, if this is an A which is left over in the middle, then that's what will happen. You'll see a A in this step. You'll back it up by 1, and you'll be looking at the same A that you just marked. That can only happen if there's that one letter in the middle. And at that point, the string should be accepted. And there should be a similar thing on the bottom branch. This is a little tricky. So if you didn't think of that, I don't blame you. So here it's a B rather than an A because I'm on the bottom branch. All right, those are two sort of technicalities that can happen if you have an extra letter in the middle. They might be necessary. All right, any thoughts about that one? This is tricky, I know. You will have much more practice with these on the homework, so check them out and let me know if you have questions. Great. I would like to move on to something a little different. Still talking about Turing machines. I mean, we're going to be doing Turing machines for the rest of the semester, which is not all that much more time. I would like to talk about the next big thing. We got 15 minutes here. Turing computable functions. This is kind of another way of thinking about Turing machines, maybe more explicitly thinking about Turing machines as computers which like have an input and an output. Now, as we've been discussing Turing machines, they kind of have an input, but they don't really have an output. They just either accept or reject. But more useful in terms of an analogy to a real-world computer or a real-world calculator or something would be a thing which has an input and an output. The way of thinking about this we call the Turing computable functions. So an ordinary, I will say a typical Turing machine just accepts or rejects. Although this, like I said, if you're thinking about real-life computing machines, usually you want them to have a more sophisticated answer, like an input and an output, not just like a yes or no answer. So a typical Turing machine just accepts or rejects, but we can view them as something like a calculator which writes the answer on the tape, all right? The tape, when the machine stops, there's something on the tape. Now in all of our examples, it wasn't very interesting. It was just like a marked up version of the original string. But a typical Turing machine just accepts or rejects, but I will say we can view the tape at the end as something like an output string. So if you read the tape at the end, then it's like an answer. It's not just a yes or no, but it tells you something perhaps more interesting. Right? This is like an answer. So what we're going to talk about in terms of these like Turing computable functions, we're going to talk about the machine as if it were a function where you give it an input and it gives you an output. And it doesn't try to say accept or reject. It just tries to give you a particular answer. So for example, here's a very simple example of a machine. This one, you will notice immediately, has no accepting states because that's not the point of it. The point of this machine is to write an answer on the tape. All right, so this machine has no accepting states. This is not for accepting or rejecting. It starts with something on the tape. It starts with a string and does something to it, right? So we can think of this Turing machine as like a function, like a mathematical function. All right, I mean it's a function about strings, but it's like a function. You give it an input and it gives you an output. It starts with a string on the tape and it does something to it. Can anybody say what does this does to the string on the tape? Maybe we could just like do a little example here. So if we started with something like if the input was, let's say, B, 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 A, B, I don't know. Think about what this Turing machine does. It starts, the head will begin in this position, right? And the first state there, the arrow says BBL, AAL. That means no matter what you see here, move to the left by one spot. And then you'll be in this state. This arrow says blank AR. Can anybody say what does this machine do to the string? Think of it as it does something to the string. What do you think?
Yeah, it's an A to the beginning.
It adds an A onto the beginning. Yeah, that's what this machine does. It starts here, moves to the left by one spot, and there's a blank there, just because there is, and it changes it into an A. So the output here is A, B, 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 A, B. All right. So here we can say the Turing machine adds an A to the beginning of the string. All right. So for the next few times, actually, our Turing machines that we talk about are not going to have any accepting states or anything. They just do something, and then it stops. Right. The Turing machine adds an A to the beginning, and then halts. That is to say, it stops doing anything. All right. Halt is a fancy word that we're always going to use for the machine stops. All right. You can actually think of the Turing machine, therefore, as a function. The Turing machine, this Turing machine is the same as the function f of x equals ax. This is very easy to write as a function, right? That is, you start with some string and you put an a in front of that same string. F of x equals ax. If you like, I could write the domain and the codomain of this function. This function goes ab star to ab star. That is, I'm going to try to think of this as a mathematical function. The domain is any string with a's and b's, and the codomain is also a string with a's and b's, and the function itself is this over here. You take your string and you put an a in front of it. All right? So the big question that we're going to be talking about for the next couple times is, what kinds of mathematical functions can you do with a Turing machine in this way? You certainly can make a Turing machine that puts an a at the beginning. All right? If some function can be performed by a Turing machine, then, can I call it f? If some function f can be performed by a Turing machine, then we say, f. F is Turing complete. Turing computable. Not complete. Turing computable. That means that this function is capable of being computed using a Turing machine. All right? That function is Turing computable. So, for example, this function up here, f of x equal ax, is Turing computable because you can do that function using a Turing machine. Could we make a machine? Let's try. So your next homework assignment will have like a big list of functions, and I will say, give me a Turing machine that computes this function. All right? It's similar to give me a Turing machine which computes a particular language, although it's slightly different. How about f of x equals xb? Put a b on the end. Can we make a function that does that? Sort of the formula for this function looks very similar to the previous one, although the machine itself has to work pretty differently, I would say. Anybody want to give me a suggested strategy here? You have to put a b on the end. Yep.
You loop through a's and b's,
Mm-hmm.
and then once you reach a blank, you add a b, and that's it.
Yeah, great. So when you say loop through, I should be moving which direction?
Right.
To the right. Yeah, we start at the beginning, that is to say on the left end of the string. So you have to go through the whole string, moving to the right, leaving everything the way it is, of course. All the a's and the b's, you want to keep them the way they are. And then he said, when you get to a blank, you change it into a b. I think we can do it just like so. Blank b, and then, r, I guess, or l. That doesn't matter. I think that's it. All right. You move through the whole string, leaving everything like it is. When you get to the end, there's a blank there, and you move to the right. Well, that doesn't matter. You change the blank to a b, and then move to the right, I guess. All right. Excellent. How about let's try some more. Actually, I wanted you all to try. I got two for you to try. How about we can do this in 5 minutes. F of x equals axb. This one puts an a on the beginning and also puts a b on the end. And then just for fun. F of x equals empty string. Think about that. I will give you 3 minutes, and then we will go over them in our remaining 2 minutes.
For the previous problem we had with the XP, we would just have another, oh wait, it would be blank.
Yeah, if you wanted XBB. Yes. Is this one of the homework problems though?
Yeah, because I just realized it's very similar to the question we did previously.
Yeah, it is, but actually what you had before was correct. For this,
was?
For this, yeah. Like in this case, I'm imagining a string which doesn't have the b's at the end, and I'm creating the b's at the end. But on the homework, it's about if you have to just check that there were 2 b's at the end. So it is a
okay.
little different. All right, can we talk about them? I know you're probably not finished yet. I didn't have time to walk around, but how about AXB? This is basically just a combination of the 2 machines that we did earlier. Here's this whole business puts an A at the beginning. So you want to do that, and then you want to do this. You can just kind of do them one after another. So to put an A at the beginning, I have to move to the left by 1 spot, and I don't care if I start with A or a B on the front. And then I turn a blank into a, and maybe go back to the right. So this is how you should start. Those 2 steps put an A on the beginning of the machine, or on the beginning of the string. And then I want to put a B on the end. To do that, I basically want to do this. Move to the right over and over again. I think I can just verbatim paste that over here. Move to the right over and over again, past A's and B's, AAR, BBR. When you see a blank, which is now at the rightmost end, you make it a B. Like that. I think that's how we do it. Anybody get something slightly different? I think this is how it should be done. All right, and what about f of x equals epsilon? That means I want to see the empty string on the tape, which I guess means you want the entire tape to be all blanks. All right, so you have to start with whatever string you started with, turn everything into blanks. How did anybody come up with something like that? Yeah, what'd you say?
I just did loop through A and B, and if there was any, just turn them to blanks.
Yeah, change, loop through A's and B's, changing them to blanks. Moving to the right, I assume. Yeah, this is good. So this will make everything blank. And then what? Actually, you don't have to do anything else. I mean, this eventually will get to the end and it will just stop. And that's what you want it to do, right? That's it. This is the whole answer for this one here. All right, great. We'll do some more interesting examples next time.